Hola todas, bienvenidos a otro episodio de Canal. Esta esto Nihalji del Departamento CSE, USN 1VE 20CS 102, haciéndose sexto SEM. Entonces en el video de vamos. So today we are going to discuss about the topic object code and object program generation for SIC machine. So this topic basically comes under subject system software and compilers. So this is a table given to the following question. So let's read what is the question. Generate object code for the following SIC source program and also write the object program, that is write header record, text record, end record. So basically you have to find an object code and object program for the following table. So let's see how we can do it. So actually the program object program consists of three things. We have to find three things here: write header, text record, and end record. So let's see how we are going to do that. So this is the mnemonics and the opcode value given. This will be given to you in the question. So this will be helpful for using for solving object code. So the table consists of line number, location counter, label, opcode, and operand. So these three things, label, opcode, and operand, will be given to you in the table, already given to you in the question. So for finding the object code, we have to find location counter first. So let's see how we'll find the location counter for all the things. So in this SICX machine, there are four types of instruction types. They are type 1, type 2, type 3, and type 4. Type 1 consists of 1 byte in it, type 2 2 bytes, type 3 3 bytes, type 4 4 bytes. So basically type 1 are single 1 byte thing. So if you find some register and all, they all come under type 2. And in type 4, if you see plus button, so in the fourth line number 4 you can see there is a plus LDB, so it means this is a type 4. So if it is not type 2 or type 4, then it is and type 3, which there. So the example for type 3 is LDA, which is here. So let's see, I will start. So basically with the sum label will start, this is start, and the operand value of starting is 3000. So the first location counter number will be 3000 as the operand of first thing is 3000. So in the opcode label will be same. We have to observe the operand. So the operand is a register. So I have already told you a register means it's a type 2. So there are two for the type 2. We have to add 2 bytes to it. So you can see here 3000 plus 2. So this is the 2 bytes which are going to be added to the 3000. So it becomes 3200. 3002. 3002 will be placed in the next location counter. So this is 3002 now. So the line number 3 is 3002. So in 3002, if we observe LD opcode and operand, it is an LDA. It is an type 3 byte because it is neither a type 4 neither a type 2. So we'll add 3002 plus 3. 3 bytes will add to 3002. So it will be 3005, which will be placed in line number 4. So in line number 4, you can see the opcode value is plus LDB. So plus here is represents it's a type 4. Type 4 has 4 bytes in it. So we have to add 4 bytes to 3005. 3005 plus 4 is 3009. So these values are basically in hexadecimal. We have to represent these values in hexadecimal. So it is now 3009. So again it is a type 3 thing. So 3009 plus if you add 3, it is 300C. So after 9 you know that it is A, B and C. So 9 plus 3 is basically 12 in the normal mathematical decimal thing, but in hexadecimal 12 is equal to C. So we have to write 300C. So this 300C will be placed in the line number 7. So again if you see TIX, it is a type 3 thing. So again you have to add three more bytes to it. It will be 300F. Then in 300F line number 8 you can see GLT. So it is again a type 3 byte because there is no plus symbol here, neither there is a register here. So we'll add again 3 to it. So now it will be 3012. So 3012 will be again placed to the next line number, that is 9. So the line number 9 has STA. So again this is in type 3 thing instruction. So 3 bytes again it will be added. So now it will be 3018. So 3018 will be placed in the line number 11. So now you can see it is an important, there are many things going to learn now. So in opcode in line number 7 you can see RESW, this means reserve word. So there is operand value 1 in it. So you will multiply. So this is a type 3, this all the three things, 3 RESW, this is an type 3 thing. So now the three bytes which are there, you'll multiply that with the operand value. So 3, this 3 into 1 will be 3. So then again 3 you will add to this 3018 plus 3, which will give you 301B. So now again if you see here RESW, so this is a type 3 thing. So if now 3 operand value is 2000 into 3, which will be 6000. So 6000 is in decimal form. If you convert that 6000 from decimal to hexadecimal, it will be 1770. So 301B plus 1770 will give you 478B, which will be placed in line number 13, that is 478B. Now if you see again, it is the same thing. This is a type 3 thing which has an operand value of 1. So 1 into 3 will be added to it. So this 478B plus 3 is 478E. So this will be the final location counter which you will find. So with the help of location counter, now for the each line number we'll find the object code for it. So let's see how we'll find it. So now for the first line number 1, we'll find the object code for it. So x is basically a register. So a register is of the form type 2. I told you already, type 2 means 2 bytes you'll add for the location counter. So the format of type 2 is an opcode of 8 bit, then R1 and R2 for following 4 bits. So let's see. So in the previous thing, you can see the opcode is in the previous, here in the line number 1, the opcode you can see is clear. So in the previous question you saw that the values for the mnemonics were given. So let's see what was it given for the clear thing. So here the value for clear is B4. So this B4 we will use here. So you can see here clear is equal to B4. So B4 can be written in the form of 10110100. So this will be placed in the opcode. In register R1 is equal to X. X is 1 here, and R2 is, there is nothing in the R2, so it will be 000, and R1 has 1, so it will be 001. So this will be placed in R1 and R2. So now at sum of this 4 bytes will take together. So 1011 value is, then 0100 is 4, then 0001 is 1, then 0000 is 0. So the object code for this is B410. So the next thing is LDA. LDA is a type 3 thing. The value for LDA is 00. So they have given 00. If we expand it, it is 00. You'll find 8 zeros here. So this will be, so basically in the form, I'll explain you what is format 3. Format 3 has 6 bit in it, 6 bit of opcode in it. Then this all are addressing modes, N, I, X, B, P, E. So I is immediate mode, N is indirect mode, X is the register, B is the base, P is the program counter, E is nothing but the value. If it is a type 3 format, then E will be 0. If it's type 4 format, then E will be 1. That's all. For type 3, it will be having 12 displacement values, 12 values in it. But for type 4, there will be 20 addressing bits. So let's see, LDA is 00. If you expand it, 8 zeros you'll get. So we'll take most 6 significant bit, because opcode has only 6 spaces in it. So we'll take most significant bits from left to right. So we'll take this 0, this 0, this 0, this 0, this 0, and this 0. So this 6 zeros we'll take it and place in the opcode. If we make the sum of this, matlab together, if we take 4 bytes together, then like this we'll get, if we take 4 for this, for this, for this, for and this, for this, we'll get 0 1 0 0. So let's move forward now, seeing the other object codes. So now it is plus LDB. So this is the type 4. You can see a plus symbol here. So it's a format 4. The format 4 has 6 bits of OP. Then all the addressing modes, and you will use 20 bits here. But 20 means 4 into 5. 5 things, 5 grouping you'll have. So in this you can see the it has as asterisk, matlab this symbol, command symbol. Basically this means immediate mode. So one will be immediate, one in the I column we will place 1, and this is type 4, so E will be 1. So if we sum this, we'll get 691047 and 8B. So let's move forward. So now for a base is an assembly directive. We don't calculate the object code for this. So base is basically an assembly directive, which means we cannot calculate the object code for it. So we have to leave it blank and move forward. So the next is add. Add, the value for add is 18. 18 can be expanded into 001 1001. So we'll take most significant 6 bits. So if you take this, it is 000110. If we'll place it here, then if it is neither indirect nor it is immediate, then we'll make both n and I as 1, and and this has an x, which means index mode. It has a register x, so x will be 1, base will be 0, p will be program counter will be 1, and e will be 0 because it is a type 3. And we can find this displacement by minusing. We can find displacement from here. Previously we were not finding displacements. From now we can find displacements. We can see displacement is basically 301b. So where is 301b? So this table, basically this operand has a table, so that table value you can see is 301b here. So this 301b will be used here. This 301b will be minused by the next location counter, that is 300c. So 301b minus 300c is 0 4 so 4 7 7 zeros followed by f. So f is basically 4111. So PC is actually found out so 1 triple 4 times 1 is basically between minus 2048 to 2047. So PC will be 1 because it ranges between these values, this limit. So the object code for this is, if you group this into 4 bytes, bits into 1 byte, then you can find the object code as 1BA00F. So the next object code now is TIX. TIX, it is basically format 3. So same thing we have to TIX, same thing we have to proceed. TIX means 2C. They have given the value of operand as 2C. If we expand 001011, 6 significant bit will take, we'll place it. Then it is neither indirect nor immediate, so 11100. P is 1 because it ranges between, the displacement value ranges between this. If you calculate the displacement 3018 count, so operand is count value has 3018. If you minus 3, if you minus 3018 from the next location counter, that is 300f, so you'll get 0000009. So 9 has 1001 hexa value, so it ranges between this. So PCP value will be 1, base value will be 0. So object code for this is 2F2009. So the next is GLT. GLT value is 38. If we expand this 00111000, object code for, if we'll take 6 most significant bit, opcode will write. Then n and I will be 1 because it is neither indexed nor it is neither indirect nor immediate. Then x will be 0 as there is no register. Base will be 0 and p will be 1 because the displacement PC relative value, because the displacement value is ff7, that is basically minus 9, which ranges in between PC value. So PC will be 1, p will be 1, e will be 0 because it is a type 3 thing. If we take all these things together, we can find the object code, that is 3b2ff7. So the next is STA. STA is 0C. If you expand it, we'll get 4 zeros, 1 1 0 0. Most 6 significance bit will take. Then N is I, both are 1 1 because it is neither indirect, same thing. Then B value is 1 here because we'll see when when we are calculating displacement, we're getting the displacement as 0. So base relative, it comes and between the base relative too. So base relative value is from 0 to 404095. So base will be 1 now, P will be 0 because it comes in the range between B base. So the object code for this is 0F44400D. So the next opcode is R sub. So R sub has 4C as it value. If you expand, it is a type 3 thing. If type 3 instruction, if we expand it, we'll get this value. If we take most 6 significance bit, we'll take it in the opcode. N and I are 1 1. Then all the other things are 0 0 0 0 because we've got nothing here. So the object code, if we calculate it, we'll get 4F followed by 4 zeros. So next, if you observe here, for the three things are reserved word, we are not calculating object code. We'll tell you why. I'll tell you why we are not calculating object code for this. For R, for reserved word, we don't calculate the object code. For end is an assembly directive. We don't calculate the object code, but we can write the starting address. For the end also, we don't calculate the object code. We directly write the starting address of it. So with this we can see that we have found all the object codes here. Base, we don't find object code for base. For reserve word we don't calculate object code, and for the end thing we will directly write the starting address. So with this we can see we have found the object code. So half question is done. So with the help of this object code we'll find now object program. So let's see how object program is basically found out. So in object program, we find header record, text record, and end record. So let's see how first. Let's start with header record. Header record basically has 19 bits of size, and the text record has 69 bits of size, and what is this? End has a small amount. There is no specific size. It will write all the 6 bits of end record in it. So let's see what is the head record. So we'll mention H, starting with H, that means it is an head record. So then we'll have we'll leave 6 bits of it, 6 bits for it. So we'll write starting label of the question. So it is sum here, you can see sum here. So we'll write sum followed by 3 blank spaces. Then we'll write the starting address of it. Then we'll write the ending address of it. So this sums up to the head record. Or we'll see text record. Text records has total 69 bits of size you can have. So we'll start with T, which means text record, then the starting address. Then I'll tell you what is this 18. So then we'll write all the objects code starting from B4110 to 4F4 zeros. We'll write all the object code together here. If we add all from here to here, if we add, we are getting the total of 48 length. So 48 columns. So basically 2 columns together forms 1 byte. Two columns forms 1 byte. 4B10. So this is four things, 4 bytes matlab 4 bits. That means 2 columns and 1 byte. So 48 bits are there. That means if you take 2 columns to it, so there are 24 bytes totally. 48 columns is equal to 24 bits. So the value, so representation of 24 in decimal is 18 in hexadecimal. So this 18 is written here. So next is end record. The end record consists of the starting address. We write starting address. So starting address is 3004, which is just 4 numbers. So we'll add 2 zeros in the starting to it, and with this we have found out object code, object program. I hope you understood everything I have told you till now. So the main motive behind this is to find object code and object program. With first we have to find location counter. The location counter we can count, we'll find it out. Then we'll, with the help of location counter, you'll find object code. So with the help of the object code, you'll find object program. So object program, we have three things: header record, text record, and end record. So this sums up to the end of the question program basically. So I hope you understood. If you have any doubts, you can mention them in the comment section. I will clarify your doubts. So, so we'll end up this presentation or this video with a small quote. So the quote is, love the life you live the life you love. So thank you one and all for I appreciate your time for this video. Thank you. I won't extend more. Thank you everyone for watching this video, watching this presentation. Thank you one and all.